Hello and welcome to this Dlubal tutorial. In this video, we will model a truss girder in Rhino Grasshopper and export the results to RFEM 6. First, we start with the geometry. We create a point using the construct point component. Afterwards, we copy this point by holding down the Alt key and dragging the component. For the second point, we set up a number slider to the x-coordinate, so that it can be easily adjusted later with the slider. We insert the number slider command from the Params tab and then double-click on it to change the lower and upper limits of this slider. We enter number 1 for the lower limit and 30 for the upper limit. We also enter a name for this slider, and for that we write total length. By right-clicking the slider, we can select the slider type, floating point, integers, etc. For example, we select floating point. After that, we create a line between these points using the line component. As you can see, when we click this line, it is colored green. Next, we determine the middle point of this line using the curve middle component, which is in the Curve tab. In the next step, we copy these points using the Move component. You can find it in the Transform tab or double-click the canvas and write Move. Now we start to copy these points in the Z direction. First, we copy the base points. As you can see, by default this value is 10 and in the Z direction. We need to insert the unit vector parallel to the Z-axis by using the Vector tab or by double-clicking the canvas, writing Z, and selecting this component. We set up a range, for example, from 1 to 5. For this, we need to create a number slider. We can do this by double-clicking the canvas and writing 1, point, and 5. After that, we enter side height for this slider name. For the third point, the middle point, we repeat the same procedure, but regarding the value in the Z direction, we insert the expression component. Double-click the expression component to open the expression editor and change the expression to x plus y, where x is the side height and y is the apex height. For this, we set up a range between 0 and 5. After that, we enter apex height for the slider name. Then we create lines between these points using the line component. In the next step, we divide these lines into equal segments using the Divide Curve component. You can find this component in the Curve tab. Then we drag and drop it from the Curve tab onto the canvas or by double-clicking the canvas and writing Divide Curve. By default, the value of the segment number is 10. We set up a new range, for example, from 1 to 15. We repeat this for other lines with the same number of segments. Now we create the verticals as well as the diagonals. We begin with the verticals. First, we need to determine which points will be connected to each other. We connect the points of the first line from the lower chord to the points of the first line from the upper chord. We start with the first lines from the lower and upper chords, as you can see. For the second lines from the lower and upper chords, we do not need to consider the first point, because it has already been considered. For this we utilize the cul index component. You can find it in the Sets tab or by double-clicking the canvas, writing cul, and selecting the component from the list. By using this component, we can choose a specific item to remove from the list. Now we need to determine which item will be removed by using the number slider command. For this, we enter 0, 0, which refers to the first point of a list. We repeat this for the points from the lower chord. Afterwards, we connect these points to each other using the line component. We group these lines by hitting Ctrl+G and writing verticals for the name. Next we create the diagonals. As you can see, we connect these points in this pattern. Therefore, we do not need to consider the first point from the lower chord, the last point from the upper chord. We can cul them using the cul index component. For the first point, we have to enter 0 as index. 0 refers to the first point of a list. For the last point, we have to enter -1 as index. -1 refers to the last point of a list. We can add the -1 to the range by double-clicking the slider and changing the lower limit to minus values. Now we create a line between these points using the line component. We repeat the same procedure for the other side. Then we make groups and enter names for all the groups, as you can see. Next, we put all the number slider commands together in a group to control all the parameters easily. In the next part, we create members for these lines. We insert this component from the Dlubal tab. We also need to define the member type using the value list command. For this example, we select the beam type. After this, we connect the line components to the Grasshopper line in the member component. In the next step, we define the cross-section as well as the material. For this, we insert the Dlubal components, section, and material. Next, we insert the panel command to enter the properties of the section and the material. Now, we enter these properties. For the cross-section, we enter 1 as the section number, and R, M1 and 120/120 as the cross-section name. For the material, we enter 1 as the material number, and C24 as the material name. Make sure that you use the correct RFEM terminology. Only then is it possible to export the elements correctly into RFEM. Afterwards, we connect the material component to the material number in the section component, and connect the section component to the section start in the member component. Next, we define the supports. For this, we insert the nodal support component from the Dlubal tab. For the first node, we would like to create a hinge support using the panel command. As we mentioned in the first example, 0 means free, infinity, INF means rigid, and in between, with a specific number, means spring. Then, we connect this panel to the respective support conditions. We repeat the same procedure for the second node but with other conditions, because we want to define the sliding supports. To transfer this model data to RFEM, we need to insert the Dlubal component, RFEM6 export component. To start the export, we utilize the button command from the Params tab for this example. As we did in the first example, we can select units using the value list command. We can also overwrite the previous data in RFEM using the Boolean toggle command. This means the all data in RFEM will be deleted before the export, once we switch to true. After connecting all the components to the RFEM6 component, we double-click the button command to perform the export. All changes to the parameters in Grasshopper now have a direct impact on the RFEM model. Thank you for watching. If you have any questions, feel free to ask them in the comments below. If you like this video, don't forget to like and subscribe. You can also visit our website at dlubal.com and search for anything you need.